Okay, now we're looking at our basic graph, x and y. X is the independent variable, y is the dependent variable. And just as we had in the table and in the tile pattern, the figure number is the x and the y is the number of tiles. So we simply fill in from the table or the tile pattern these values, but we need to create a complete graph. Part of that is having a scale. So our scale on the bottom is 0, 1, 2, 3, 4, 5, etc. Going up by 1 because that's what the figure number does. We went up by 3s and we started at 0. We always start at 0 on a graph, but actually in a moment you'll see we started with 1. So we're going to have 1 here and then we'll go up 3. So what we'll do for the scale factor here is we really have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think that was the maximum we got to. 0, 1, 2, 3, 4. We're going to put in 1, 4, 5, 6, 7. And why are we labeling those 8, 9, 10? Because 11, 12, 13 actually was the top. Those are the numbers you'll see. Those are the coordinates that we actually have to graph. And going back to our table, 0, 1 was the first one. We go, when we plot a coordinate, we look at the right-left movement first, and the first point is 0, 1. So 0 indicates we're not moving right or left at all. We're simply going up 1. So our origin, or our figure number 0, is the point 0, 1. Then in the table we have 1, 4. So we go over 1 and up 4, and that's where we're going to graph the next point. After that, we are going to 2 and 7. So we go over to the right 2 and up 7. Again, we always move left or right first, and then we go up and down. So again, our last or third point is 3, 10. Go to the right 3 because 3 is positive, and we go up 10 on our graph, and you can see a line forming. Last one is 4, 13, and this is forming a line like this that starts at the point 0, 1. It does not start at the origin, it starts here. But the origin of this graph is of course 0, 0, right here. Now, how does this work? What does this mean? Well, you can see visually on a line, when I put that arrow there, I can extend that out. This is actually growing at a constant rate. And then if we were to extend this out to figure 6, 7, 8, 9, 10, 11, and we extended this line out, then we can see that our graph, reading off our graph, we can start to see the correlation with the total number of tiles. So a graph can be very, very powerful, very useful. Later on in the course and in mathematics, you start to see curved graphs and various other things that involve something that is not a constant rate of growth. This is, again, 3 every time. So let's look at our rate of growth and the change in y in connection to graph terminology like slope. The slope is found by going over 1 and up 3. 1, 3, it's called a staircase. 1, 3, and keep going. 1, 3, 1, 3, okay? And we keep going like that. That's called the rise over the run. The slope is the rise over the run. M equals rise over run equals slope equals 3 over 1 or 3. And of course, that's exactly what the growth factor was when we did our tile diagram. It's exactly what we got when we compared y values on our table. And as it should be, because that number 3 is constant throughout all the different representations. What else is constant? What other number? I'm sure you're thinking the y-intercept right here. That number right there, which is the value, in this case 1, is called b. b equals 1 equals the y-intercept. And what is that in our tile diagram? That was our figure 0. So going back, this is how it is. It's at the point 0, 1, where the line crosses the y-axis, the y-intercept. So those two numbers, 1 and 3 in this particular problem are very important. You're going to see now when we finish this off that when we write an equation or a rule that those two numbers are going to be very important.